All right, I'm going to go over the confidence interval for the population mean using the standard normal. The standard normal is your Z. And so the formula is that you're going to take X bar, which is the mean, plus and minus Z sub alpha divided by 2 times the standard deviation over the square root of n. Now I find it best on the ALEKS calculator to put parentheses around that, just so that it calculates that a little bit better. We're also going to use the graphing calculator just to verify our answer. So we're using the Z interval. What you do is hit stat, tests, and number 7 is for your Z interval. So we'll do it both ways. So this first one here, it says, a laboratory in California is interested in finding the mean chloride level for a healthy resident in the state. A random sample of 70 healthy residents has a mean chloride level of 102. It is known that the chloride level in healthy individuals residing in California have a standard deviation of 36. Find a 90% confidence interval for the true mean chloride of all healthy California residents, then complete the table below. So looking at this problem, we know that N is 70 because we had 70 healthy people. X bar is 102, and that the standard deviation is equal to 36. So when you use this formula up here, the one that we're going to do on ALEKS, when you do the 90% confidence interval, you're actually going to take 100 minus 90, and that's 10% that you're going to use, because when you're doing your standard normal curve, the 90% is in the middle, and so the two ends are 10%, and that's why we have to divide it by 2 in the formula, because you're going to have 5% on this side and 5% on this side. So plugging that into my formula, I'm going to have, first of all, 102. I'm going to do the minus first. Z sub, and I'm going to use 10%, so 0.10 divided by 2, times the standard deviation, 36, over the square root of n, which was 70. So I'm going to go over here and pull up my ALEKS calculator and punch that in so you can see how it looks on the ALEKS calculator. So I'm going to do 102 minus the Z sub, 10% divided by 2. You could just divide that and put 5% in there. 10% divided by 2 would be 5%. And then in my parentheses, I have 36 divided by the square root of 70. Go behind there and close that parenthesis. So it's going to look like that on your calculator. 102 minus Z sub, 10% divided by 2 times 36 over the square root of 70. If I enter, I get 94.922. I'm rounding to 1 decimal place, so 94.9 is where I would have that. Then I'm going to do the exact same thing, only instead of using the minus, I'm going to do the plus. So a shortcut on your ALEKS calculator is just to undo what you had there and go up to the formula that you put in there, and instead of doing the minus, I'm going to backspace. Whoops, I didn't want to do that. I'm going to have to highlight that, I guess. There. Highlight the minus, change it to a plus. It put an extra box in there. Well, we'll get rid of the minus. Well, it was almost a shortcut. But you want the exact same formula that you just did, just with the plus sign in there instead of the minus sign. So when I do that and I enter, I'm going to get 109.0775, but rounding it off to 1 decimal place, 109.1 then. So going back over to my paper here, I got 94.9 to 109.1. Now just to verify that, I'm going to use my graphing calculator. So on the graphing calculator, we said we were going to hit stat, test, and 7 to do the z interval. So on my graphing calculator, I'm going to zoom out a little bit here. I'm going to hit stat down here. Oops, I could turn it on, that would help. Stat, cursor over to tests, and then do number 7. Number 7 I'm going to cursor down to, but you can see next to number 7 says z interval. I'm going to enter on that. Now this one we are doing statistics. We're not putting our data in the list. If we had a whole list of data, we would type it into data and use the list. Again, my standard deviation was 36. My mean was 102. N is 70. Now here's the difference on here. My confidence level is 90%, so I'm going to use 0.9 as opposed to on the formula we used 10% divided by 2. And so I'm just going to leave that as a 90% confidence interval. And then I'm going to go ahead and go to calculate. And you can see that my answers, I got 94.922, which we rounded off to 94.9. And then I got 109.08 because it rounded it up, but we're rounding it to 1 decimal place, so 109.1 is where we would round that off to. And you can see I got the exact same answer either way. So I'm going to go ahead and pull one up here on Alex. Slide this over so you can see the problem. Hopefully you can read that. We'll zoom in a bit. Okay, so this one says the lifetime of a certain brand of battery is known to have a standard deviation of 11.5 hours. So I'm just going to note that on my paper. My standard deviation is 11.5. Suppose that a random sample of 60 such batteries, so N is going to be 60, has a mean lifetime of 46.1. So X bar is going to be 46.1. Based on this sample, we're using a 99% confidence interval. For the true mean life of all batteries, then complete the table and we're going to find our confidence interval. So, got my numbers down that I need for my formula. Again, I am going to take 100 minus 99, which gives me 1%. And so I'm going to use 0.01 when I use my formula. And so X bar is 46.1. I'm going to start with the minus. Z sub, the 0.01 divided by 2. And then in parentheses, my standard deviation, which was 11.5, over the square root of n, so over the square root of 60. And so my formula is going to look like that. I'm going to go back over here on Alex then. Going to go to the calculator. And I'm going to put in 46.1. Start with my, 46.1 minus Z sub 0.01, 1%, divided by 2 because I have 2 ends on my standard normal curve. Parenthesis, 11.5 was my standard deviation, divided by the square root of n, which was 60. Close my parenthesis. And so I'm going to enter on that. And I get 42.3 when I round that off. It's 42.275, but 42.3 then would be my answer. Then I'm going to do the exact same formula, so I'm just going to do undo. And I'm going to get rid of the minus, change it to a plus. This likes to add that extra space, so once you change it to a plus, just go ahead and backspace over that extra box that it has there. You got to be in the box when you backspace. And so I've got my formula in there. 46.1 plus Z sub 0.1 divided by 2 times 11.5 over the square root of 60. I'm going to go ahead and hit equal there. And I get 49.92 And so that rounds off to 49.9. So, looking back at my piece of paper here, my two answers, 42.3 and 49.9. Now, before I put that into the answer on Alex, I'm going to double check it with my calculator. I'm going to zoom out again here. Turn my calculator on, go to Stat, cursor over to the word tests, and then pick number 7. You can just press the number 7. It's going to bring up the Z-interval test. Make sure Stats is highlighted, which it is, and then put in your information. My standard deviation was 11.5. My mean was 46.1. And my N value was 60. And this time my confidence interval, we used the actual one from the problem, which was 99%. So I'm using 0.99 when I put that in there. And I'm going to cursor down and hit calculate. And then I'm going to look, see if I got the same answer. So I got 42.3 when I round that off, and then 49.9. 42.3 and 49.9. I got the same answer both ways, so I probably have it correct. So I can go ahead and enter that in on Alex, 42.3 and 49.9. And if I check that, you can see that we got that correct. All right, hope that helps you out with these ones. Just be careful when you do that alpha value, that when you do it on Alex, you're going to take 100% minus the given percentage, and then on the formula, you divide that by 2. When you use the graphing calculator, you just use the percent that's listed there in the problem.